Namaskar, welcome to Economics Point. In this video, we will discuss how to formulate linear programming problem involving maximization. Okay, linear programming problem involving maximization is a mathematical technique. Okay, by which the optimal values of the structural variable or the basic variable can be obtained so as to maximize the objective function and subject to some constants, okay, which is generally expressed in the form of inequalities. Okay, and this problem can be formulated with the help of the following hypothetical examples. Suppose a farm intends to produce two goods, okay, good one and good two. Further, assume that production of each good involves three processes, process 1, process 2 and process 3, and the maximum capacity, that is maximum time availability in three processes, are given to be B1, B2 and B3 respectively. Okay, and time required to produce each unit of a good in each process is also known. Okay, and prices of the good one and good two are given as P1 and P2 respectively. Okay, and the problem before the farm is to take into decision relating the quantity of a good one and good two to be produced so that it can maximize total revenue. Okay, so above information given to the farm, this can be put forth in the following tabular form. Okay, so you can formulate the table like so. Process and the time required to produce each unit of good one, as you know, that is good one and a good two, and the maximum capacity is given in the problem. Okay, so there are how many processes. This assumes that there are three processes, process 1 and process 3. So there are three processes, process 1, process 2 and process 3. Okay, and there are two goods, okay, good one and good two, and the maximum capacity, say the maximum capacity is maximum time availability, that is three processes are given to be B1, B2 and B3. So this can be written as here, this is B1, B2 and B3, and see the prices of a good one and good two are P1 and P2 respectively. So we can write here price, okay, price of a good one is P1 and price of a good two is P2. Okay, suppose in process 1 good 1 is produced, then this becomes here A1 1. Okay, and this represents in the process 1 good 2 is produced. Okay, so next one, this represents process 2 and good 1. Okay, so a 2 1, and this represents process 2 and a good 2. This is a 2 2, and this column this cell represents here in process 3 good 1 is produced, that is a 3 1, process 3 good 1, and a 3 2 means process 3 good 2. Okay, now we have presented the above information in the tabular form. Now on the basis of the information given in this table, okay, we will formulate a linear programming that is involving maximization. Okay, so our step 1 should be step 1 is statement of the objective function. Statement of the statement of the objective, okay, function. What is our objective function? Our objective function, say, is to maximize profit, isn't it? So that say so that it can maximize total revenue. So our objective function is to maximize revenue. So maximize revenue equal to P1 x1 plus P2 x2. Okay, so this is your revenue. P1 represents what? Price of a good one, and x1 represents your quantity of a good one. Okay, and P2 represents your price of a good 2, and x2 represents your quantity of a good 2. And P1 X1 this represents, okay, revenue obtained from sale of a good 1, okay, and P2 X2 this represents revenue obtained from sale of a good 2, okay, and this R equal to P1 X1 plus P2 X2 means total revenue obtained by the firm by selling these two goods, okay. And next step will that is statement of the structural constant, okay. So after statement of the objective function, the next step is statement of the structural constant, and it is calculated on the basis of a inequality, okay. Here there are three constants, okay, because production of the good involves three process, okay, and maximum capacity is also given as b1 b2 and b3, so there will be three constants, okay. So our first constant, this will become a11 x1 plus a12 x2. This should be less than equal to b1. Okay, where a11 represents time required to produce 1 unit of a good 1 in process 1. Okay, and x1 this represents amount of a good 1 to be produced, and a12, say this represents time required to produce 1 unit of a good 2, 1 unit of a good 2, okay, in process 1, and this should be less than equal to B1. B1 is the maximum time available, that is for process 1. So our constant number 1, this will become, say, constant 1, this will become a11 x1 plus a12 x2, this would be less than equal to b1, okay, and a11 x1 plus a12 x2 represents total time required to produce x1 of a good 1 and x2 of a good 2 in process 1, clear. And then next constant, this will become a21 x1 plus a22 x2, okay, and it should be less than equal to b2. So our next constant, this will become a21 x1 plus a22 x2, this should be less than equal to b2, okay. Here a21, okay, this represents time required to produce, okay, 1 unit of a good 1 in process 2, okay, and your a22 this represents time required to produce 1 unit of a good 2 in process 2, okay, and your a21, see, a21 x1 and a22 x2 this represents total time required to produce x1 amount of a good 1 and x2 amount of a good 2, and this should be less than equal to b2, that is maximum time available in process 2. This is the maximum capacity in process 2, okay. Then next constant, this will become, okay, a31 x1 plus a32 x2, and this should be less than equal to b3, where a31 represents time required to produce 1 unit of a good 1 in process 3, okay, and a32 this represents time required to produce 1 unit of a good 2 in process 3, okay, and this a31 x1, okay, plus a32 x2 this represents total time required to produce x1 of a good 1 and x2 of a good 2, and their maximum capacity in process 3, it should be less than equal to b3, okay. So these are the three constant, and non-negativity constant, these are x1 and x2 should be the non-negativity constant, that is x1 and x2, this should be greater than equal to 0.